All right. Well, welcome everybody. Good evening, good morning, good afternoon, wherever you are in this world and out in television land. It is an absolutely stunning day here in Madison, New Jersey. Temps probably may be in the 70s and 80s degrees Fahrenheit range. So thank you for coming out and spending some time with us. I know a lot of us after a long day would prefer to be home as well, but we appreciate you coming out here and supporting us.
I certainly know I prefer to.
So, yeah. But yeah, we do this once a month, right? So, but yeah, so our standard agenda for those of you who've been here in the past, we thank our sponsors. We talk about what's new. I'll introduce Garima, who will then do her presentation, and then after she's done, quickly go through what's coming up for us. There's been some updates since we last met, and so that's a good thing. So we were getting a little worried about not having anybody. Sorry, my phone is ringing and it's in my ears, so it's so I'll have to work through it here. But yeah, and then so we're pleased that we have we're booked through September. Yeah, I did. Okay, there we go. Thank you. They say you shouldn't let it go to. You shouldn't cancel it early. So
it will still go to.
Oh, does it go to voicemail? Okay. Yeah. But yeah, so but yeah, and then so this is great. So we were actually booked through September. Of course, we're still working on booking out the rest of the year as well. So stay tuned for all that. All right. So of course, our gold sponsor is Payara. They make the Payara platform, but I think with the acquisition of Agzul, I think they're calling it it's not platform anymore. I don't know. Dominica, who works there, told me the new name. I forgot what it was. But in any event, it has Azul Payara in it. But they make their Payara server, Payara micro. I don't know if they're moving forward with the Payara cube, but we'll find out. So in any event, it's a middleware to deploy your applications and to run them. And speaking of Azul, they have been our silver sponsor. And of course, they make their downstream distribution of OpenJDK called Zulu. There was a recent Jakarta Tech Talk, or no, maybe it was one of Azul's webinars, where Simon Ritter, the deputy CTO at Azul, gave his talk about migrating from Oracle JDK to Azul's JDK. Our partner is DevNexus. Next year's conference is in Atlanta again, but actually it's in early April. I think I want to say the 3rd, 4th, 5th, 6th, something like this. But yeah, so we look forward to participating in that. Our per meeting sponsors, of course, Romanelli's, our local pizzeria, only 5 minutes away. They give us a great discount on the pizzas. JetBrains, of course, as you're familiar with them, they have all their IDEs. IntelliJ IDEA, of course, for us. WebStorm, PyCharm for Python, and so on. And then, of course, the Eclipse Foundation and Jakarta EE offer free crowdcast hosting for Java user groups. Our memberships, of course, as you've seen this all the time here, right? The Microprofile Working Group, the Jakarta EE Working Group. We are guest members, but I always like to participate, so I attend all the meetings once a week. The ambassadors, I'm on the leadership team for that, and then we have the virtual jug as well. Oops, I went too far. All right, what's new? I mentioned this once. We are partner members now, thanks to Barry, in the Java community process. We did not go the elected route, so this gives us a chance to be part of this. Of course, the JCP, they sponsor they have the whole expert group for each of the Java releases, and Simon Ritter being one of them. And then Barry participates as an individual member. So I don't think we're held to the same strict standards if we were elected, right? Because I think Chandra told us that you have to be at every meeting or miss a minimal of whatever. So I think this is good for giving us some more exposure as well. Um, Java 27 is in ramp down phase 1 as of the 4th of this month. There are a total of 9 JEPs. There were 10. One of them backed out right before ramp down phase 1. But that's what happens, right? This is the beauty of the 6-month release cycle because, you know, as one of the Oracle guys told me last year at Java 1, he said, you know, everybody tried to get all these features in because it would be 3 to 4 years before the next release. Well, it doesn't matter now because it's every 6 months. I don't think I updated it, but one of these was going to be finalized. I think it was 538, the bottom one, Pem Coatings. It's now a 3rd preview. There was some last-minute feedback right before it was going to be targeted, so they changed it to a 3rd preview. So probably in Java 28 it'll be finalized. So these, you know, so again, this is the beauty of the 6-month release cycle. So these are the 9. Okay, it's a little bit less than the last few years, but it's a non-LTS release. Let's see. Vector API, 12th incubator. This is contingent upon Project Valhalla moving forward. I just saw something on the mailing list today about JEP 401 with object value class, object something and value classes. They want to actually move it forward, and this is one of the JEPs that are part of Valhalla. So we think we might see some movement there. I think that's awesome. So stay tuned. So what else? Oh yeah, and then here's the release schedule, which was finalized. So ramp down phase 1, as you can see, was last week. Then you have your phase 2 and your release candidates, and then September 14th it'll be available. Jakarta EE12, yeah, I think, you know, they keep having milestone releases, multiple. I haven't updated this slide in God knows how long. So in any event, there has been movement with that. They want to have the core profile released by the end of this year, and then the web profile and the platform released 1st quarter of next year. And before I move on to what's new for us, we've been telling folks, my wife and I will be first-time new grandparents later this year. Wow. We are looking forward to that. My older stepdaughter Molly and her husband, who live in Rhode Island, they've had some difficulty in this, and when it was all said and done, they're having twins. Wow. And it's twin boys, so we are pretty psyched. My stepdaughter has already warned us that chaos will ensue in our house when those boys grow up. So we shall see. So, but so not only do the parents' life change, I think the grandparents' life will change as well. So we'll see. We're really excited about this. You know, we're probably holding off on conferences to see how much, you know, we might go up to Rhode Island and help out with all that. So I think the due date's December 6th, but you know, given any history with my wife and everything, those kids might come earlier. So we don't know what Thanksgiving's going to be like, but that's the news, you know, that I wanted to share with everybody. So we're really happy about that. Okay, enough of me talking other than introducing Garima. So let's see. As you know, Garima joined the leadership team back in April, so we appreciate you helping out, you know, with that. And Leia's here. I think the both of you weren't here when I introduced you guys last month. Yeah. But yeah, we appreciate your help. And Leia has already made some changes to the website to make the photos look much nicer than what I originally had. So, but Garima is a software engineer and community leader with strong expertise in Java, backend development, and cloud-native technologies, specializing in building scalable, high-performance distributed systems. She has worked across complex domains, including banking, insurance, mortgage, e-commerce, and government, collaborating with some of the world's largest organizations in these sectors. An IEEE senior member, Garima is an active speaker at major global technology conferences and a frequent judge at hackathons and innovation programs, where she mentors and supports emerging talent. She is also an active book reviewer with major publications. Garima is deeply passionate about Java and the evolving intersection of Java and AI. Committed to fostering collaboration and knowledge sharing, Garima actively contributes to growing and strengthening developer communities. She is also passionate about supporting women and technology. So that's a nice CV for you there. So, so without further ado, Garima, please, the floor is yours.
Thank you so much.
So, okay.
Welcome everyone. Thank you so much for taking out time and driving out here on this nice summer evening. I really appreciate. So as Mike already introduced me, so I'll not introduce myself again. I'll directly start with the talk. So today I will be talking about blocking is the new non-blocking. So I know this title is little provocative, or I'll say contradictive, but I have designed it in the deliberate way. So as in this session, we are going to talk about the threads. So threads is a very critical feature in Java, which major of the sectors is being using. Suppose if I'll say about trading, so billions and trillions of the dollars has been trade every single day around the world. Even Java threads is the heart of many other sectors like healthcare, e-commerce, or I'll say banking, insurance. So if I'll say these applications are running on Java, then I'll say thread is their engine. Without further delay, I'll start with today's agenda. So I have divided the whole talk into 4 main parts. In the first part, I will be talking about what are platform threads, or I'll say traditional threads. In that, I will be telling how the threads has been created, why they are called blocking threads, and what are the problems we have faced while working on platform threads. In the second part, I will be talking about the reactive programming. Majorly, I will be talking about completable future because as a Java developer, we mostly use completable future, and how completable future has solved the problem of platform threads, how we have achieved non-blocking, what are the concurrency patterns we have in completable future, and there are some problems which we face through completable future. So in the part 3, virtual threads, I will be talking about how virtual threads has solved the problem of both platform threads and completable future. So virtual threads come as a part of Java 21 with Project Loom. It is JEP 444. So in virtual threads, we are just going to add one line of change and the whole threading structure will be changed. In part 4, I will be talking about structured concurrency by focusing more on the structured task scope and the scoped values. So before starting the talk, I want to share a small story that will be helpful around the whole session. Imagine it's a Friday night in a restaurant kitchen. Orders are coming in and restaurant is very busy. There are only 5 chefs in the kitchen. And according to the traditional platform, each chef is supposed to handle 1 order at a time. Now, 5 orders has been taken by the 5 chefs. Suppose chef 2 is now done with the preparation and he has put the dish in the oven. He is doing nothing. He is just folding his hands and waiting for the oven to get complete. Similarly, all 5 chefs are standing outside in front of the oven and waiting for the dish to get complete. They are all blocked, doing nothing. So orders are coming in, chefs are blocked, they are not preparing, they are not serving the dishes very fast. So restaurant is feeling exhausted, customers are getting frustrated. So to solve this problem, the restaurant has decided, let's redesign the whole system. So now they have decided, now each chef is not going to handle the single order. They have decided to divide the whole order into small tasks. And now each chef will take care of one task at a time. Now, same chef 1 is taking care of the vegetables. Chef 2 at the same time is taking care of the stove or oven. Chef 3 is taking care of the plating. And 4 and 5 chefs are taking their own task. So the tasks are moving smoothly. No one is getting blocked. The restaurant is happy. Customers are happy. But there is a catch. Now the system has become very complex. And if any of the tasks get failed, the whole dish is spoiled. So the restaurant has found out that it is very difficult to trace where this issue has happened. So the restaurant has decided, let's move back to the traditional one. Each chef will handle one order at a time, but with a twist. Now, when a chef is standing in front of the oven, he will not be standing. He will take up another task, and he will be putting a timer on the oven, and when the oven beeps, the chef will come back and take care of the previous order. In that way, now the orders are not blocked. They are served in a smooth manner. The restaurant is happy, the customers are happy, and kitchen is working fine. So these are the three kitchens and the three uh, trading techniques we are going to I'll going to explain. In kitchen 1, I will be telling in the part 1, that is what are traditional threads or the platform threads. The kitchen 2, I will be what are completable future or reactive programming, and how the virtual thread has solved the problem of both platform threads and the reactive programming. I hope if you have any question in this story, I can solve it now so that the next slides will be smooth. Okay.
Do you think virtual threads make reactive programming obsolete?
Obsolete? No, no, no. It cannot. So if the system is still in the using the reactive programming, so virtual threads cannot remove the completable future or reactive programming. But if your request response, like I'll say, that is a small your if your API is small, like not doing any structured, like too much asynchronous task, then that is a better one to use it. But if you want your the request response time to be fast, we can move to virtual threads. Because if you are not having it is just in virtual threads we are adding a single line to make the thread enable as a virtual. So it will be better if your APIs are not too complex. That time virtual threads is a good decision. So what are platform threads? Platform threads, when a request comes, a thread has been created, and each thread is being connected to one OS thread. So when a thread goes into the blocking, then that single thread is in the blocking state. So in the first line, that is the most important part of the platform threads, that one Java thread is connected to one OS thread. So every thread is taking a space of 1 MB, that I'll say call stack. Call stack is kind of a notebook which will manage what the method a thread is calling, what are the local variables it is managing, and to save all this information, it takes almost 1 MB of space. And these threads, the scheduling is being managed by the OS here. It depends upon how many core of CPU you are having. So at the same time, only those many threads will be working. So context switching is near to 1 to 5 microseconds, since if I have a 10 core CPU, then only 10 threads are working at the same time. So once the thread execution change, they have to manage some of the information, the thread which was running. So to manage that context switching, we are having it takes 1 to 5 microseconds. And lastly, the Tomcat provides a default thread pool of only 200. So if requests are coming, the application can handle only 200 requests at a single time. On the left side, this is the thread life cycle. So the thread life cycle is having 5 stages. The new is the one which is at the new stage. The new thread has been created. It is not started, it is just created. Runnable is the most efficient stage, where the thread is actually doing some work. Block, when a thread is waiting for when block is waiting to acquire a lock, suppose a DB lock or an HTTP lock or a IO lock. Waiting is the most inefficient stage, where the thread is doing nothing. They are just holding the CPU and doing nothing. And lastly, when the thread work is done, they are terminated. That is the last stage. So I'll explain what are platform threads with a small demo. So I have created a controller of kitchen only, And I have created 2 records. One is the chef, we are just having a chef name, and one is the order, where we are having an order ID and the chef who is handling that order. So I just want to fetch all the chefs who are working in a kitchen presently. So it is just having an HTTP, like I'm not using the HTTP client call right now, just having one fetch service, and where I have just put the threads in a sleep for 1000 milliseconds, or I'll say 1 second. So I will test this get request using a JMeter to put a load of around 1000. So my thread load is 1 minute. So I will be pushing 1000 threads at a time, and the ramp up time is of 10 seconds. So we will see the performance after 10 seconds, and the thread execution, the request will execute for next 20 seconds. So you can see at here the threads are getting, the requests are getting called. It is 1000 at a time, and after 10 seconds we will see the performance. Yeah, so I'll display the graph. So it is taking 21 milliseconds, and since as I mentioned, the default thread pool is of just 200, so only 200 requests will be handled. So gradually the graph has increased, the requests are getting more time. It is near to 84 milliseconds. So if I add more, if I want to fetch, suppose I want to fetch orders based on each chef. So first I have to call the chef service, where it will take around 2 seconds, or it will take around 2 seconds, and each chef I have a fetch order service where I have put the thread to sleep for 500 milliseconds. So that is like half second. So if I'll call 5, so I have created a list of 5 chef here. So when I call 5 chef and each chef is getting the order, it is going for sleep for 500 milliseconds. So the whole request will get complete in near to 3.5 seconds, or else this one will take 1 second, sorry. So this request will take 3.5 seconds, and I will be using the same 1000 threads to call this request. I'll just change the So again, the 1000 threads are calling the same request and the same ramp up time of 10 seconds. Now you see, last time it was nearly 8 milliseconds, but now it is, because since we are calling through each chef, we are calling the orders, it is now increased to 12 milliseconds to 72. The last one is executed at 72 milliseconds. So we can see when more load is coming to the service, the execution time has increased. So what are the problems with the platform threads? So I've divided into 2 parts. One is the CPU waste, and another one is the memory pressure. We have seen that if a thread is in a waiting or blocked state, it means they are not doing nothing, but they are holding the resource. CPU is not doing anything, but still they are busy. Suppose there are 200 threads are calling the request at the same time, and all are going in a waiting state of 200 milliseconds. So all 200 threads are in a idle stage. So our CPU shows that it is healthy, only 4% is being consumed, but still the requests get rejected because no thread is free. They are still in a waiting stage. So to solve this problem, if you say we can add more threads, that is not going to help. If we add more threads, more threads will go into idle stage, and it will be a more wastage. If we look about the memory thing, so as I mentioned in the starting, one thread is taking around 1 MB of stack. So if we can increase the size, but default is 1 MB is the size called stack size. If 200 threads are calling, then 200 MB of stack memory is being consumed. So if we increase more threads, then the stack memory will get increased. Like if I want 10,000 threads, so it will be holding, itself is holding 10 GB of stack alone. So that is not the efficient solution. So to solve this problem, to call the request in an asynchronous manner, uh, in Java, in JDK 8, completable future has been introduced in 2013. So now it is a non-blocking approach, and it works in concurrency pattern. It is a powerful tool. The throughput has increased as compared to the traditional threads, but there was a problem that it was complex. We can see this. So what is completable future? It is a Java API that runs the task asynchronously, and all the tasks are connected through a chain. So these are the follow-up steps which are connected through a chain. So they are not working in a blocking manner. They are executed in a non-blocking. So instead of waiting for the result from any of the IO or any HTTP request, so they start doing the another task. So the calling thread anytime is free, and it immediately take the another task. So what problem the completable future has solved? So that before, the thread was blocked during every database call or an HTTP call, but now with the completable future, the threads are free. The OS threads are now free, and they can serve the another request. The result of completable future or reactive programming is that we have achieved the high concurrency using the same thread pool of 200. And the key APIs in the completable future is you use apply async, then you chain all the subtasks using then apply, and lastly you compose the results of all the asynchronous tasks. So I'll just give a small demo of completable future. Now the same chef API I will be calling in an asynchronous manner. So what this service does, I will be using supply async on my to get the result. So here I will be expecting the output to be in a completable future. So it will be a list of chef, but using apply async on using a lambda expression on each chef, I will be using, so I cannot use thread.sleep here. If I'll use thread.sleep, then it will be again in a blocking manner. I will be calling a blocking. So I will be using delayed executor to put the thread into in a delay execution of 1000 milliseconds. But the response will be better this time. So again, I'm calling 1000 threads, and the ramp up time is 10 seconds. We'll see the results. So the number of threads are calling threads are. So now you can see using the same service, but it is an asynchronous manner, and the response time is just 1 second. So all 1000 threads are being executed in 1 second. So now the throughput is very high as compared to the platform threads. Now if I want to fetch all the orders for each chef, I will be using the in an asynchronous manner. So what we see, first we have to fetch all the chef in an asynchronous in a chef future, and on each chef future I will be again calling async method. For each chef I will be calling the orders using on each chef I will be calling the fetch order in an asynchronous manner, the same, and I have added a delay executor of 500 milliseconds, the same we have added for order in the example of platform threads. And lastly, after, since it is completable future, is since we want the result to be in a completable list of completable future, but with this we are getting a list of completable future of each order. So we have to map it to a list of completable future. So you on the order future I will be streaming and mapping it to a completable future dot join and to list. So again I will be calling the API using 1000 threads.
Have you tried something like a million threads for just for grins?
For this one?
For grins, try a million threads.
No.
No.
I have not
Be
tried.
interesting to see that.
We can try it now.
Okay,
only.
yeah.
I'll put it.
Well, we try 100,000.
Yeah, let's try. Yeah, we can try it. Yeah. So the so we can see the graph. We have added since we have added a delay of 500 milliseconds for each order. So now the starting time is near to 1.5 seconds, and it has decreased. So the graph is itself showing how completable future has solved the problem of traditional threads in terms of the response time. So let's, yeah.
I noticed that you're using string applications there.
Yeah.
String has its own reactive paragraph. What do you think about it?
Yep. Yeah, it has its own, but I didn't thought about it.
Reactive. Yeah, reactive string.
Reactive, yeah.
Oh, yeah, webflow.
But since like we are only using, I have not hands-on Webflux or Mono. Like I'm into this completable future, so I have taken this as a example. Yeah. So you want to like let's check with the.
Yeah, if you want to do 10,000, let's say.
Yeah. Yeah, it's going.
Reactive programming can be powerful, but it's way too complicated.
Yeah. Yeah, so the response time has increased when more threads has been added.
The old as n approaches infinity.
Yeah. Yes. So these are there are some problems with the, yeah. So there are 4 points which is being faced with the reactive programming. that is, it is very hard to write. To write the logic, you have to chain all the logic together, like each task to be chained, and these are again you are adding in the form of a lambda. uh, so and if you want to, for each subtask, if you want to handle error, then again it will be again adding a few more chains to handle those exception handling. So it becomes very hard when you add more requirements. It becomes very hard to write the code. Similarly, if writing is hard, then reading is itself is a hard. So when you write like 20 lines of chains of executions, then the business logic, the exact business logic get hide in that chain. So there are like then apply, then async apply, and then compose to merge the results. So these things becomes more tough to read. So even the developer who writes the code, if he wants to understand after 6 months, it becomes very hard to understand it. And if you want to test it, writing the JUnits, again, it was a difficult task in a asynchronous manner testing, because you have to mock all the futures, and even if you have adding exception handling in each chain, then testing those exception has also become very complex. Then if I'll say the compatibility, if in single system you are having like webflux also mono, and like if you have computable future, then integrating those libraries together is, it's very difficult. So because of these issues, like in with JDK 21 we got virtual threads. So the line itself at the bottom says you are writing the code in a blocking manner, but the performance you are getting in a form of a non-blocking. So virtual threads was the part of Project Loom, and JEP 444 is the OpenJDK page where you can see what is the design of virtual threads, what are the advantages. Everything has been mentioned in JEP 444. So how virtual threads work? So in the platform threads, we have seen when a new thread is created, that get attached to a OS thread. That is one virtual thread, one traditional thread is equals to one OS thread, that is mapped 1 to 1. But here in virtual threads, the virtual thread is handled by JVM, but though traditional threads were handled by the OS. So here the virtual threads are being handled by the JVM. So JVM manage all the scheduling of the virtual threads. So if we have 6 virtual threads, then they tie it on a 2 career threads, or I'll say OS threads. So what happen if a virtual thread go in a blocking stage? It unmounts from a career thread and goes into the heap. So the career thread is now free to get the work for other virtual thread. In that way, the virtual thread can come up again, and if any career thread is available when their blocking stage is done, they can come, and it is not necessary that they have to mount to the previous OS thread only. They can mount to any career thread which is available. So they store all their stages, like whatever information where they have left, all the information about the variables, about the method, they store it in a heap memory, which is just takes space of 1 KB, less than 1 KB. So yeah, when an IO operation gets complete, the virtual thread remounts or free the career thread and resumes exactly where it left off with the other career thread. So we'll see the example of virtual thread. So the beauty of the virtual thread is you have to just add one line in your application.properties that spring.thread.virtual.enable true. So the system will automatically now start running on the virtual threads. But the necessary is your application should be on Java 21. It cannot be, yeah.
So I'm ashamed to admit that I actually am not familiar with this particular aspect of Spring. Whenever I use virtual threads, it's always just install Java thread.virtual, virtual task executor, stuff like that. Obviously, for Spring, a lot of those threads aren't managed by me anymore, and I have no idea. I assume this isn't going to turn every thread virtual, because then
Yeah.
hypothetically, if every thread's virtual, then they're all daemon threads. The process closes, for example. So I'm kind of wondering like which threads become virtual, deciding which ones don't, because some of them have terminated platform.
Yeah, we can use thread.off virtual like to create the virtual threads. But yeah, this will definitely make all the threads as a virtual threads, this property.
Every single one.
Yeah. Yeah, threads will convert into
Concurrent
virtual.
will create virtual thread. also any executor plus decorate something like that also will be virtual thread. You can create manually if you need. I have to say executor which will be using platform thread, but it's up to you.
I see. It's just that there should be at least one platform thread there, otherwise this whole process will shut down. Like if every thread's virtual, then every thread's a daemon thread. The process shuts down because there's no platform threads left.
No, it will be, because you need to platform thread to execute virtual thread. Virtual thread will mount it, execute it, then unmount it. This is logic.
Platform threads sit behind the virtual threads. They sort of underlie them, right, or something, right?
That's right. Yeah.
But traditional threads will be there, but virtual threads will be at, mounting on the OS threads.
Yeah. Most likely disadvantages of virtual thread because you have only one pool of platform thread for all virtual thread. That's why this will be exhausted. Your application will stuck. It doesn't matter how many virtual threads we can create, because we have like one pool for platform thread, which I manage at virtual thread.
I suppose the point is really getting though is that one platform thread or how many platform threads are left can't be allowed to finish. Because if it finishes executing and the threads are have left, the process will shut down. I should know. No.
And I think I need to read more about this one. Like I didn't thought whatever I have gone through the resources, this much I have understood. So I'll definitely look around this one and will come up with this. Like how if all are virtual threads, then it will be like shut down the system completely. Like, all the time. Yeah. So the same now we'll call the same chef request in a, now this will be being called in a virtual manner. Like virtual threads will be called to call this request. Let me restart. Let's see the response.
So you kept it at 10,000?
Yeah, now it is 10,000. Continue. 1 minute.
Oh.
No, it's not this. It is going till 20 seconds. Let's wait. Yeah, now all 1,000. Yeah, so even the graph is, earlier it was going till 8 milliseconds, and here since we have put 10,000 threads, it is starting from near to 1.5 seconds and goes till 2 seconds. Not 1.5, it is near to 1 only. Till 1 second to 2 seconds. But let's try with the 1,000 threads. What is the response? But as compared to the platform threads and the completable future, the response time is like is similar to the reactive one, the completable future, but the code reading the code is simple right now. We are using the same blocking code, but the performance is better. Yeah. So earlier we have seen with the traditional thread, it was going till 5 seconds, but here it is for 1,000 threads only. It's the same as the computable future, 1 second. And if I'll call the orders request, So in the orders, we are having 1 second calling all the chef, and we have added 500 milliseconds for each order to be fetched for each chef. That is like 2.5 seconds. So total, it's 3.5 seconds for each request to get complete. But through virtual threads, it will be, let's see the graph. It is same 3.5 seconds for all 1,000 requests. So this is how the virtual thread has achieved the throughput as similar to completable future and without compromising the simplicity of the code. Now we'll see about the structured concurrency. So structured concurrency, in structured concurrency, we will be achieving, we will be looking at the structured task scope and scoped values. Structured task scope is still in the preview stage. It is not yet finalized, and scope value is finalized with Java 26. So what structured task scope do? It is in the 4 parts I have divided. First, it is very easy to create, like each subtask is being handled now by virtual thread. So if I am having 5 subtasks in a single request, then those 5 subtasks will be handled by virtual thread. So all 5 subtasks will be running in an asynchronous manner parallelly. Then managing effortless error management, it means if you want, you can use joiner in your structured task scope. Joiner is help in managing the exception handling. If you want all tasks to be complete and then and wait for the, like, you want all tasks to be get complete whether an exception occurred or not, you can manage it through the joiner interface. Even you can create your own joiner method by implementing the joiner interface, and you can create your own logic for your all subtasks. And lastly, the code has become very readable, simple, very easy to read. You can see all your subtasks very easily understand, and you can test your code. So I'll show with a small demo for structured task scope. So what I am doing in the structured task scope, I am first fetching all the chef, as I have done with the in the starting, using the fetching the chef and putting the 1,000 milliseconds as the waiting. And then for each chef, I'm fetching the orders. But now I have put the order in a subtask, like using, I have defined a scope, which is a structured task scope, and where each order is being fetched as a subtask from the chefs which I have fetched. So here the order is of, so you see the return type of order is a subtask. It is not a order record. It is a subtask, structured task scope dot subtask of order. So now after that, once everything, all the subtask has been executed, I will be joining the response, and in the end I will be getting all the subtasks and putting into a result, into a list, and uh, returning back in the form of a list of orders. So we will see again the response is similar to 1 second to fetch the order, to fetch the chefs,
and 500 milliseconds to fetch each order. So now the response time is 1.5 seconds for these for each this get request. Since we are putting fetching each order in a form of a subtask, so the response is just 1.5 seconds while fetching the orders for each chef. Huh?
What's the advantage of using those subtasks?
So subtask is basically you first that is running on a virtual thread. So each subtask is each subtask is being handled by a virtual thread. So but before this, if I'll use completable future and we'll put each task in a asynchronous manner, then they were not running, only single thread was handling it. But here we are using virtual threads for this one in the subtask. And even the reading, earlier it was chain of lambdas, but here now we are having it is very easy to read. Yeah.
So I'm not familiar with structured concurrency and some of these newer features. When it comes to kind of stuff, my knowledge typically ends at virtual threads. I'm kind of wondering if there's a way to have actually platform tasks in some cases, because I can see a situation where if your tasks are compute tasks, then you actually would want to platform thread it. Virtual threads, they could work for compute, but it's not ideal, especially with pinning. So I'm kind of wondering if that's just an option. Obviously, for the sake of concurrency, we're discussing purely virtual threads, tasks running on virtual threads, IO-bound tasks, but even still, it feels like there should be a way for a platform task to exist here, and then we have all the same benefits, obviously exception handling per task, stuff like that. It works. I assume that's something. I assume that's possible to have a task on a platform thread.
Yeah. So while we're on that topic, Anbu online was just making a statement because he had asked about the discussion we had just a short while ago. And he said, I guess Spring runs platform threads for main application and request and response uses virtual threads. So that, yeah. I guess that makes sense. I never really, never really studied it. So
That makes sense. Yeah, that's the IO-bound part.
Right.
That being request and response. So,
Because yeah, virtual threads are self attached to the OS thread. So OS threads are there, main function, like they run the main one, but virtual threads work top on the OS threads.
Good conversation. I love it. Even even the folks watching remotely are are getting involved here. So good stuff. So.
Yeah. So let me share one more example of the structured task scope. Suppose I want to fetch all the orders for each chef with more details. So first, what I will be doing, I have to fetch all the so for each chef I have to order yeah. So I have a list of 5 chefs. So on each chef, I want to fetch orders by passing the chef as an argument in a structured task scope. So again, I have declared a structured task scope, and there I am I'm streaming on chef list, and for each chef, I'm calling another method called fetch order with structured task scope with the chef name. So what I am doing, I'm fetching the orders for that chef, putting again adding thread.sleep for 500 milliseconds, and I'm creating this subtask of fetch orders. Then I'm creating subtask to check what order has been placed for that chef for particular order. So suppose this is my new record where I have the list of recipe names.
And in that I have a list of, suppose this is my order contains these three dishes. So I will be putting in details of each order. And lastly, I am putting my pantry. Suppose um, if pantry is empty, so I have just added a runtime exception to see, like, for each ingredients I should add some condition here, but I'm just throwing in runtime exception. So for that pantry check, that ingredients are missing. And lastly, what I'm doing, I'm combining all three subtasks and returning back the order. But here you can see I have added a joiner. What this joiner do, this is for handling the exceptions in between the subtasks. So I have called joiner is an interface where we have four methods. Joiner provides four ways to handle the exception. That is, first is all successful or throw. If all subtasks are successful, then only send the, otherwise just if any one exception thrown, then send the result back. And in between the just stop the scope and give the response. Any successful result or throw. If any of the result is successful, just stop it and send the response. Then await all successful or throw. If all are successful, then wait, otherwise just throw the exception. And await all is where they wait for all the subtasks to get finished, and lastly uh, merge the response and send back. So I am using await all. It means if any exception is throwing by any subtask, the whole execution should get complete. It should not throw in the middle of that. So, but you see in the third task, in the third subtask, I am throwing an exception for each order. But still, my whole my request will get complete. So I'll just demo this one. Again, the 1000 threads, and we'll wait for this execution to get complete after 20 seconds. So you see the execution time is just 1 second, since we have put the sleep of 500 milliseconds, then 300 milliseconds, that is near to 1 second only. So you can see there is no exception has been thrown since we have used joiner method of await all. So we'll just show you all this I have shown, like you can create your own joiner method by just implementing this joiner interface, and you can create your own exception handling by creating your own method. These are pretty much enough for the handling the exception, but still if you want some specific logic to be handled for exception handling, you can create your own joiner class. So these are four joiner dot await all. It means you have to wait for all subtasks to get finished. Joiner, if you want, it should throw. If any of the subtasks fail, you can use all successful or throw. If you want, returns one, if any one of the task is succeed, you should stop the execution there, and it should return back. And all until predicate, it means you are passing one condition, and if that condition is that condition is met anywhere, it should stop the execution there. So one more feature we have, that is the scoped values. Earlier we used, still we have thread local. So thread local is basically a variable which is being used during the execution to manage the, some values we want to be used in a logging, or I want to, for the trace, I want some variable, some information about the thread I want to display in my logs. So earlier we are having thread local,
but now Java 26 has provided a scoped values. So what happened with thread local, that the value is mutable. You can change the value of the thread local anytime during your methods. Like in one method I've set another value, in the second method I can change the value. But with the scoped values, this value is immutable. Once you set the value of the variable, it will be immutable. Next, inheritance, that the when you set the value of a thread local, then in the child subtask the value will not get inherited. The child subtask will be showing null value for that thread local. But when you set a value in the scoped value, that value will automatically get inherited by the child virtual thread. With the thread local, you have to remove, in the end you have to remove the variable local thread local. If you don't, then in the end that create a problem of memory leak. I'll tell you. Suppose there is one career thread and there is one virtual thread, and I have set a value for that thread local. Now that virtual thread is in a blocking mode, so the virtual thread moved to the heap memory, but that thread local is created on my career thread, my OS thread, so the value is stored still on my OS thread. Now the career thread is free. If new virtual thread is coming and start using the career thread, mount on the career thread, that value is available to that new virtual thread. So this cause a problem of memory leak. But in the value of for the scoped value, that value gets cleaned automatically once the scope gets finished. So with the virtual threads, there is a problem of leak, but with the scoped values, there will be not the problem of leaking of the values, because that value is inside the inside that scope only. So the scope values, I see it's garbage friendly because it is being removed automatically. The value gets, yeah. I think.
Threads, because of course the variable lives on the carrier thread in this case, but it seems like with scope value, never mind like thread scope, we might have even more granular control for where a variable doesn't exist. In which case, would I ever need to use thread local after I think this is JDK 25 that got scope
Yeah.
value?
Yeah. So now, like if you are using like scope values, you can use if you are having like above JDK 25. Like it was not available before. Like it is get finalized in JDK. I think 26 is the scope value is final.
21,
25 or
yeah.
26,
And,
yeah,
and
yes.
structured concurrency is in its 7th preview for
Yeah, it's in
JDK
the
27.
structured
Yeah.
task, but it is not finalized.
Right.
yet.
Right. Yeah.
It's not?
Not yet. No.
Like it's in
Yeah.
preview stage
Oh,
right
man.
now.
Oh man, it's becoming like Valhalla. It's been in preview for enough versions that we need to loosen it.
Yeah, we need Brian Getz to really, talk about the whole Project Valhalla thing.
Yeah.
It's, you know.
They're gonna do it startup.
So I'll just show you just a small example like how thread local work and how the scoped values work. So you see, I have created a two thread local. That is, I want my whatever chef is handling the order, I want that chef name and I want the order ID. So I have created two threads, and in the starting only, I am putting the value of my chef name and set the value for the current chef name, and the order ID, which is like what is the order and the times, the current time milliseconds. Then for the structured task scope, I am creating a same the current chef and order ID, but here we are creating a scoped value dot where current chef is the chef name, and I'm calling my structured task scope, and same order ID is in my current millisecond. So these two values will be fixed in my whole execution. So this value will be displayed in each log for my
the chef name and my order ID with each subtask. And similarly, I'm using the thread local for my each subtask. Now we'll see the difference, what is the difference with thread local and what is the difference with the scoped values. So suppose if I'm calling thread local, you can see the recipe for pasta, which is my dish name, I have used directly, I have not changed, but my thread local is my chef name and my order ID. So the chef name is printed first time, but it is not being displayed, it is showing null for all my subtasks. Everywhere it is null. But if I'll change it to the scoped value, means the value is not getting inherited to my subtask. But I will just change with the scoped value, the same logging, but we are still having the chef name and my order ID is available in my all subtasks. Means the value is getting inherited with my all the methods which are being called in that scope. So this is the advantage of having scoped values when you want the values to get inherited in your subtask, which is not being fulfilled by the thread local. So what we have seen the whole session, like we have seen how platform threads were working, what was the limitations with the platform thread, because I have seen like during the initial years of the Java, major of the application has been built on platform threads during 2000s, but to fix those problems, like completable new feature has come up, that is reactive programming, and I have take an example of completable future which came in 2013 with Java 8, JDK 8, which helps in fixing the problem of blocking in non-blocking manner, and even the throughput has increased. And but the problem was the code was very complex to read, write, and even the test. So JDK 21 has come up with a solution to achieve uh, the the good thing of both platform threads and the completable future, that simple coding but high efficiency, high throughput. So through virtual threads we have achieved that one. And in the end, like JDK 25, the structured task scope is being handful in achieving the structured concurrency. The code is more readable, and even the throughput is good as with structured task scope, and scoped values has helped us to overcome the limitations of the thread local. So these are the resources which I have gone through during my presentation. I have to prepare for this session. These are to learn about what are virtual threads. So JEP 444 has a good script, like you can see a good article. In JEP 2525 shows more about the structured concurrency, like the structured task scope. 506 is the scoped value, what is the design and what are the benefits of scoped values. To know more about Project Loom, you can check the OpenJDK. All our information is on OpenJDK. Then I have used some of the articles of InfoQ on virtual threads. Then I have, taking reference from these two virtual threads talk of Devox UK by Kristin. So these were very helpful and very in-depth explained. So if you want in-depth knowledge about virtual threads or about the whole threading, you can just go through these YouTube videos. So I will be uploading if you want to refer, I will be uploading this demo code and even the JMeter plan with the slides on my GitHub repo. So you can just take a reference from there. So yeah, that's all. So the real innovation is not doing things faster. It's about how you can make
the things scalable and make the things in a simple manner. It should feel that it is simple. So blocking is the new non-blocking. Thank you.
Any final?
Any kind of
I wonder if anyone tried to do thread dump with the virtual threads, and if there's any difference.
Thread dump, yeah.
Yeah. It's always great to do a lot of experimentations. Let's do 1,000,000 threads and see what happens, right? So.
I mean, like a kill -3, like, you know, like a
Oh yeah, yeah.
like a thread dump.
Yeah.
I see. You'd have to make sure that's actually running though, because odds are it'll probably just be saved on the heap, so it won't be on the carrier stack when you do it. Because of course, for the most part, you're gonna run an IO bound task, so it's gonna be on the carrier stack briefly, gonna do whatever it needs to, and that's gonna go right to the heap. And then obviously the carrier stack will be for another thread, or probably nothing at all for a while. So.
Yeah. I'm just curious, like if we, I mean, sometimes in the past we ran into issues where we have like a deadlock or like some system is stuck somewhere, and taking a thread dump was useful to figure out what's going on, but I don't know if that gets any more complicated with virtual threads or something.
So I had a question. You did your scenarios with the chefs. It reminded me of the dining philosophers problem. Is that based on that, or?
Yeah.
Yeah. That was one of the things way back in computer science when I took it, so, where he talked about threads and
Threads.
concurrency and all that. So, but it made me think of that. Oh, thank you. So of course, I I had mentioned the honeymooners before we got started, and Barry, you'll like this. You talked about completable future, and your one variable was chef's future. I would have done chef of the future. See, I told you he'd like it.
All right.
It's a classic episode about. You'd have to see it to understand it. So, but anyway, yes.
Thank you.
Thank you very much. Any other
Thank you.
questions?
Yeah.
So, all right. Anybody out there in TV land? No? All right. Let's then wrap up, and then we actually get to go home in daylight. Wow, that's a novel, I think. And by the way, sorry about last month when the whatever game was going on over there created a complete chaos getting out of here. So it must have taken me a good 20 minutes to get onto Madison Avenue there. So, Garima, thank you very much. That was awesome. So just to wrap up, upcoming events. The Kansas City Developer Conference, otherwise known as KCDC, is in early to mid-September. We have a 10% discount code, as you can see there. So I'd like to go to this one of these fine days. I'd like to see Kansas City and get some good barbecue, right? That would be fun. Barry, you going KCDC?
I'm not, but
You're
I've
not.
been to Kansas City and had Arthur Bryant's barbecue.
Oh, that sounds
Great place, great place.
Nice.
Almost killed myself there.
but yeah, so that's always so Billy Commando gave us this discount code for that. Dev2 Next, stay tuned. We are again a community sponsor for this conference. This is probably the third or fourth year in a row that we've done this. Venkat will then, just like he did for Arc of AI, you can fill out a form each month to be part of a raffle for a free ticket. So we had 3 of us from here attend that. I think, Vlad, you were one of them, weren't you? Or no? For Arc of AI? No, maybe? Okay. Oh, was it you, Boris? Okay, at Dev2 Next, right. I know. Arc of AI, okay. Yeah, I know. So this is a great thing for that. And then, then I'm sure there'll be a discount code, but that he hasn't given that to us yet. So stay tuned. I'm sure there's other upcoming events. A lot of them are going on in Europe right now. DevOps, as you had mentioned, there was a couple of those. But yeah. And then upcoming for us, and I thought about this as you're giving your presentation. So Billy Corando will be visiting with us, but on a Wednesday. It's on July 8th. He's going to visit Philly on Tuesday, us on Wednesday, and then New York on Thursday. We went through his list of topics and we chose Luminated Java, but we'll have 2 talks in a row on virtual threads, so we may have to rethink that. But and then this sort of kind of, you know, the way it played out. Gerrit Grunwald and Ivar Grimstad were here 3 years ago in September, and the way everything worked out, they'll be here again this September, again, and also on a Wednesday. And I think they're gonna follow the same tour, being Philly, us, and New York. And we don't have an abstract yet or a list of talks from which to choose, so stay tuned for that. It was kind of funny, we were discussing Ivar visiting with us after Jakarta 1, because that's in December and it's in Ottawa, Canada. So we were wondering if he would come down, you know, and make the Northeast tour right after that. But as it turned out, Gerrit's going to be visiting Ottawa and doing a tour up in Canada with him. So, but yeah, but this is good. I'm glad to have them both here again. Gerrit is a developer advocate at Azul. Ivar is the Jakarta EE dev advocate at the Eclipse Foundation. So both great guys. But yeah, so if you haven't seen them before, here's your chance to do so. And then with that, Friends of GS Jug, some of them haven't, as you can see, I have placeholders in there. The Dublin Jug, I think you can do them online, and that should have been actually June, so I messed that up. But yeah, and somebody had theirs already. I think Chicago had theirs. And let's see. Oh, so the Boston group will be meeting this Thursday. Somebody with Douglas Hawkins talking about JVM garbage collection. And New York Java SIG, and we didn't get her last name yet, did we, Barry, on who that might be? Also this Thursday. Okay, yeah, we think. So, yeah, so that's it with some of our folks, some of the, you know, so our friends. Central Iowa, I thought I saw something on theirs, but I didn't see it on their meetup thing over there. So also, if you could sign in with the QR codes, I'll actually display it. Oh, the winner of last month's IntelliJ idea was Syed Adi. Is Syed here, per chance? Oh, there you are. Congratulations. So yeah, use that. You know, it's a 1-year license. So let's see. What else? Oh, these are just resources you can actually peruse on your own. And there's our QR code. If you wouldn't mind signing in, put your name in for a chance to win a 1-year license to IntelliJ IDEA. I think our rule is what? You can't win within the next 6 months if you win, or something like this. So that's our only real hardcore rule on that. So with that, we'll be back here July 8th on a Wednesday. Of course, you'll hear from me in email and whatnot. And there might be some more pizza left. We get to go home in the daylight. So thanks for coming out on this lovely evening, and we'll see you next month.